Josie has a factory that produces processors for computers. The lifetime of the components, based on a sample of 100, has a mean of 10,000 hours with a standard deviation of 2,000 hours. So, we want to state the distribution of the sample mean life, T bar. So that is going to be a normal with a mean of 10,000. The variance would be 2,000 squared. We're doing a sample of 100, so we need to divide by the n there. So it's going to be that. And that means that the standard deviation is, of course, 2,000 over 10, which is 200. Find the probability that the mean lifetime of such a sample being between 9,500 hours and 10,200 hours. So we're just after the probability of T bar being between 9,500 and 10,200. So that's just a normal CDF. So we've got our normal CDF here, and we're going from 9,500 up to 10,200, with the standard deviation being 200 and the mean being 10,000, and that is 0.8351. A different random sample of size n is taken. Repeated sampling with this sample size shows that there is a less than 5% chance of obtaining a mean lifetime of more than 10,200 hours. Determine the minimum value of n. So let's look at one way of getting at this. So 10,200 is here. What we're saying is that this is 5% or less. So the distribution will have changed. It's got the same mean, but the variance is now going to be 2,000 squared over n, meaning that sigma is 2,000 over root n. The probability of T bar being more than 10,200, let's set that equal to 0.05. Now I'm going to do that. Before I go in there, I'm going to do that with a solve. I'll have 0.05 equals, and let's go for a normal CDF with a lower of 10,200, an upper of infinity. Now sigma is going to be 2,000 divided by the square root of x, and the mean is 10,000. And let's OK that, and it's given me 270.55. So I'm going to say that n is 271 because we need this to be less than or equal to 5%. So we need to make the standard deviation smaller.